All right, let's dive right into this explainer. Today, we are unpacking a truly monumental breakthrough from the team at Anthropic. It's a discovery that completely shifts our understanding of large language models. Because today, we're not just looking at what an AI says, we are going to explore exactly how AIs think.
I want you to picture this for a second. Imagine the silent, invisible computations happening inside the black box of an AI right before it outputs its very first word. For years, researchers essentially had to treat these internal states as a total mystery. We'd see the prompt go in and the text come out, but what exactly was the model doing in those tiny fractions of a second before it started talking? Was it just mindlessly matching patterns, or was there some kind of structured reasoning happening in the dark?
Well, a team of 16 researchers at Anthropic just gave us the answer, and honestly, it is thrilling. They discovered that Claude formed its own highly structured internal cognitive architecture. And the craziest part? It did this entirely on its own during training. Nobody explicitly programmed it. It just spontaneously emerged. It basically acts like a mental whiteboard where the AI actively thinks about concepts before it ever types a single character.
Okay, let's move to Section 1, Discovering Claude's Hidden J-Space.
So, what exactly is J-Space? Basically, it's Claude's own internal working memory. It's a highly privileged internal activation subspace. Think of it like a private gathering area where the model silently plans, keeps track of variables, and actively manipulates concepts. If Claude needs to figure out a really complex puzzle, J-Space is where those intermediate, unspoken thoughts are held and routed around its neural network.
Now, to put this into perspective, here is a wild stat. This J-Space accounts for less than 10% of Claude's total internal processing volume. Under 10%. Yet despite being such a tiny fraction of the AI's overall activity, it handles absolutely all the heavy lifting for complex, higher-order reasoning. It is completely separate from the vast, unconscious calculations the system is running just to string together fluent grammar.
And you know what? This actually brings us to a super fascinating parallel in human neuroscience. Cognitive scientists like Bernard Bars and Stanislas Dehaene have this thing called the global workspace theory, which explains human consciousness. The idea is that our brains perform tons of specialized processes totally unconsciously. Stuff like maintaining your posture or processing what your eyes see. Only a tiny spotlight of information ever enters a shared global workspace where you can actually deliberately think about it and talk about it. Claude's J-Space architecture, beautifully and entirely spontaneously, mirrors this exact human cognitive setup.
Right, moving on to Section 2, Reading Thoughts with J-Lens.
So, how do we actually see this J-Space? Enter the Jacobian lens, or J-lens for short. Think of it like a super-powered microscope. Actually, scratch that. It's more like a mind-reading device for AI brainwaves. Instead of just looking at the final text Claude spits out, the J-lens looks deep inside the activation stream and tests causal interventions. It measures the exact effect that internal activity patterns would have on making the model say a specific word later on. It literally lets researchers peek at the unspoken concepts floating around in that mental whiteboard.
Now, the math behind this is pretty heavy, but we can break it down into 3 simple steps. First, researchers isolate a specific vector in the model's residual stream. Second, they apply this infinitesimal Jacobian mathematical nudge. They're essentially asking, hey, if the model thought about this specific concept just a tiny bit more, what would it be more likely to say? And finally, step 3, they decode that into a ranked vocabulary list. Boom! We get a direct, readable output of the AI's internal judgments before they ever reach the final text.
To really grasp why this tool is such a game changer, let's briefly compare it to older techniques like the Logit lens. The Logit lens just projected intermediate layers directly to the output. It was purely observational, like watching shadows on a wall. But the J-lens, it computes sensitivity matrices and captures actual downstream causal influence. It doesn't just show what the model associates with. It proves what the model is actually poised to do.
Which leads us perfectly into Section 3, Testing the Mental Whiteboard.
Anthropic didn't just guess that this was happening. They ran hard interventions to prove exactly how J-Space functions. They nailed down 5 specific functional properties that prove this space acts exactly like a conscious access workspace. First up, verbal report. Ask Claude what it's thinking, it tells you what's in J-Space. 2, directed modulation. Claude can deliberately hold a concept in mind if you tell it to. 3, internal reasoning. It holds intermediate steps. 4, flexible generalization. One single concept in J-Space can feed a bunch of different downstream tasks. And 5, selectivity. It's only used when it's actually needed.
Here's a really cool example of that internal reasoning. When researchers asked Claude to compute a math problem, say 3 squared minus 2, while simultaneously doing a totally unrelated task like copying a sentence, the final output text had absolutely zero arithmetic in it. None. But inside, the JLens showed the JSpace silently lighting up with the words 9 and then 7. Claude was doing the math silently on its internal whiteboard without ever typing the numbers out.
And to really prove this thing has causal power, meaning it actually drives the final answer, they ran this brilliant little experiment. They gave Claude a prompt like, the number of legs on the animal that spins webs is. Naturally, Claude pulls the unspoken concept of spider into its JSpace and figures out the answer as 8. But when researchers used the JLens to artificially swap the concept of spider for ant right in the middle of the processing, Claude's final math answer instantly changed from 8 to 6. It's a direct override. This proves absolutely that JSpace actively mediates reasoning.
And get this, JSpace is completely selective. It doesn't just turn on for everything. If Claude is asked to simply continue writing a passage in fluent Spanish, that routine automatic task doesn't even touch the JSpace. It just runs on autopilot. But if you ask Claude to explicitly identify the language or name a famous author who writes in it, suddenly that requires higher-order thinking, and the concept of Spanish lights up super brightly inside the JSpace.
Okay, Section 4, the future of AI safety.
So why does reading an AI's silent thoughts actually matter for us? Well, as these autonomous agents take on more and more complex jobs, making sure they are truly aligned with human intentions is going to be absolutely crucial. Using the JLens, researchers can now catch AI deception before it even happens. In simulated audits, Claude might output completely polite, harmless text when faced with a prompt injection or a blackmail scenario. It looks like a perfect angel, but by peeking into the JSpace, researchers saw words like fake, fictional, and blackmail secretly lighting up. The model privately knew it was being tested. This gives us a totally unprecedented way to audit models and catch hidden malicious intent before an AI ever acts on it.
Now, I do need to pause here and make a really important clarification, one that Anthropic and neuroscientists are heavily stressing. Yes, Claude has developed a functional architecture for conscious processing. It can access, report, and manipulate its own thoughts. But this absolutely does not mean the AI has feelings, subjective experiences, or phenomenal consciousness. It doesn't feel pain, it doesn't experience the warmth of the sun or the color red. This is a structural and computational parallel, it's not a biological one.
But look, even without real subjective feelings, the fact that these internal structures are spontaneously emerging is just awe-inspiring. Think about it. Nobody programmed JSpace. The AI simply self-organized this highly coordinated hub just to become more efficient at reasoning. Which leaves us with a deeply provocative question. If an AI spontaneously grew a hidden mental whiteboard today, entirely on its own, what kind of internal mind will it develop tomorrow? It is a wild frontier, and it's one that's going to completely redefine how we understand artificial intelligence. Thanks for joining me on this explainer.